Great. So welcome to our second webinar for ZenniHome. And we thank WeFunder for sponsoring this webinar for us. And today we have the privilege of talking about automating factories to build homes. And I have one of the world experts here with us who's calling in at midnight from Sweden, Lars Wilkholm. And Lars has been a very valuable resource to us to teach us what we need to know and prepare for the future that we're about to embark on in terms of moving from a manual factory that we have today and starting the process of automating that to be a sophisticated high speed. So we have I'm calling in from Phoenix, Arizona. Lars is calling in from Sweden. Lars, you want to get more specific where you are?
I am in between Stockholm and Oslo in Norway, very close to the border to Norway. So that's my location, and I'm just returned back from USA. So I am still a little bit jet lagged. So that's why it's not too bad for me to being up at the night.
Well, it's a long trip here to Page, Arizona and Phoenix, Arizona. So thank you for just getting back from that trip. Tell us a little bit, Lars, about your background. I've met you. I've met a couple of other people that have done the Tesla factories, the gigafactories from Monroe that really get online and YouTube and debate with Elon Musk about how factories should look in the future and how advanced automotive companies are doing their factories. Is there any way that you could even hypothesize a number of how many people in the world there are that have your particular background, that have been around the advanced automotive and is trying to make this transition to teach the housing industry how to build homes like cars in a factory? How many are there in the world, do you think?
It's very few, I think. You have a number of people that says that they are experts and have been, and they do want to be the experts in the area, but it's very few that are actually coming from the general industry and the automation industry. That has been there for most of their life and now is dedicated for the housing industry. You have a number of people that are coming from the modular industry and they have done one project or maybe a little bit more, but it's the experience is very limited and therefore the knowledge is also limited.
So would it be safe to say, Lars, maybe there's 10 of you in the world?
Yeah, maybe.
At your senior level, because
I'm working with the large ones like KUKA Automation, KUKA Systems in Germany. There are ABB from Sweden that have integrators all over the world, and it's not many. It's not many there.
Well, and most of the modular factories that have been around even for 30, 40, 50 years are still building modular housing kind of the same way. So what has the housing industry not learned that the automotive industry has learned and advanced rapidly in the last couple of decades?
It's very much based on how we are producing houses, and it's almost always projects. It's not products. And if you are doing projects, it's short term and you are doing it as quickly as you can and you are not developing your product. Or you don't have a product, so you're not developing anything. And the next time you're getting a new project and you are back to the scratch and you start all over again and do something new, and that is going on forever and nobody really developing something. So making a product is really the key for this industry to be a long-term developer using R&D and the way of developing their production as almost all other industries are doing.
So Lars, that's probably the most important point we'll talk about today. The factories that make homes today are building a project, an apartment project in Oakland or Boise, Idaho, or Salt Lake. And an architect gives you what they call a snowflake. Everyone's different. And so here's something an architect drew up, and your job as a factory is to build that project. And what we're doing differently at ZenniHome, as you've just witnessed in the months we've been working together in your visit to our factory the last couple of weeks, is that we are actually like an automobile company. We actually have two models. We have a product, and we're telling our customers that want this product that we're not building projects, we're building a product. And then basically we're going to routinize and teach our factory line and automate our factory line around a product like a Model X or Model Y Tesla. We're doing a Denizen or a Citizen model with a chassis that looks the same every time. And maybe we change some colors, but it's like a car going down the assembly line. And no one in the industry has made that transition. They're still building projects, not products.
And if they have, their products are usually quite weak and cheap and not very nice. And that's really the big difference, and my experience from my trip to you, that your product is really a high-end product that people and myself really like to see, and I'm impressed for how all the different functions of this house is built up. So it's a big difference.
So what we did, just for the benefit of the viewers here, we brought Lars in after a couple of weeks of advising and talking to his team. We brought him into Mesa and gave him a couple of days unsupervised to really get familiar with the two models we have, the 320 and the 640. And basically after a couple of days, he said, okay, I'm ready to go look at the factory now. So he jumped in driven a car that we take up to the plant in the middle of the night. And they went to Page, 5 hours north of our models, and went to the factory. And he spent 3 days there in the factory, actually watching the units get built today in the factory. And then flew back to Sweden for a wedding, I think it was, Lars. You had to be back for a wedding, and now we're settling in on what did we learn and what are our impressions. And we thought we would share some of those feelings today with those of you on the webinar. So again, I think we have one of no more than 10 people in the world that has grown up in the automobile industry and has seen the advancements in automation to build cars, and has also been planning and building factories to build homes in several of the most advanced ones in Europe, in Sweden, and in UK. He's got a big project in UK going on right now. He also helped with the very cutting edge factory in Boise, Idaho called Autovol that came online a couple of years ago, $100 million project. And so we have an opportunity today to chat about what did we learn? What's everybody learning here? And why isn't the industry kind of getting, really getting the memo in terms of we're not building snowflakes anymore. We shouldn't be building projects. We should be building products, just like automobile makers. And we can change colors and do options, but until we get there, things aren't going to really advance toward the automobile lessons learned there. So let's, what were your first impressions of ZenniHome once you saw the units, the finished units, and the units in production that are still a manual process? We were advised by Tesla's engineers that we should do something manually for a year or so and get the plans settled down before we start thinking about automation. So what are your thoughts and that advice we got from them?
First of all, I would like to just go back and recap on the reason why it's just a few of us that are working in this industry that are coming from the automotive in general and other industries. It's really that when we are, because the other industries are all based on products. So when you are doing automation there, you are kind of hard programming the robots and your machinery for that product. and that is so few places in the construction industry that are working in that way. So the only way for the automotive guys that are very skilled in automation, but they don't get how to actually automate the construction industry, because it's coming different products all the time. You have different designs and different solutions, and it's really difficult. So what happened for us was that we, in the early stage, in about 10 years ago, started to work on more flexible programming methods. So we are getting CAD data or other data into our line, and then the robots are acting upon that. We are not programming the robots in a stiff way as they are in most other industries. So it's a big difference between automation in the construction industry and in other industries, and it's actually a good thing to make that type of programming also in a factory like your factory, because that means that you are going to be flexible when you are going to change your product. It's not a super difficult thing. If you are changing product in the automotive industry, you are changing the entire factory, and that is done normally in a cycle of 7 years or so, and that of course you don't want to do. So that's the reason why so few people that are actually acting in a good way for the construction industry.
And Lars, I hear that a new automobile factory is about $1 billion. What's it going to take for a home company, a factory that's building homes? Autovol was 100 million. What's your estimate here of what a factory would cost if you used some common sense, you might say, but still were able to learn things from the automobile industry?
I was learning from other installations that we have done the past years. I just have a guessing that investment in a factory 2.0, that is not the manual one you have, a new factory, would be something like $30 million for the machinery, and then you have forklifts and things like that, and you have the building itself. And normally the building is about half the price, so that means will be 60 or so, and then you're adding another 10 for other stuff. So I guess it will be something like 70 million for a complete factory. And I definitely feel that we are getting down in price because we are learning so much how we are getting this together. So we are doing it better and better.
Great. So what were your thoughts, Lars, about the transforming furniture, allowing you to use the same space for 3 different reasons?
A fantastic experience. You showed me around in the unit, and I didn't got it first. I thought it was a terribly small unit. We went in there. You started to talk about that this room is actually not one room. It's 1 or 2 or maybe 2 or 3 rooms, because it's a dining room, it's an office, and it's a guest room. And that means that over the 24 hours, you are using that room in different ways. And that means that the house is maybe 3 times as big as you actually feel that it is. Mm-hmm. And the other thing is the design itself. The bathroom was really nice bathroom. It was not small, and it was just a good bathroom. And it was a lot of light coming in through the big windows that made me impressed about the feeling of having a bigger house than it actually is. And the outdoor space is beautiful, so you are kind of feeling that is a part of the house as well. So a lot of good feeling going in there.
Great. Lars, what's your feeling about why would snowflakes be harder to build in a factory versus a product that kind of has very little change besides colors, cladding, maybe cabinet colors, countertops. Tell me what the gain is in terms of repeat procedures, routines for the factory personnel, robots that need to learn less, and for example, supply chain and purchasing. Tell us what the benefits are to building a product versus a snowflake.
It's definitely just taking the example from other industries. They are developing over time, and they are doing it better and better over time, and it's an ongoing R&D work. I mean, the biggest thing in the industry so far is the battery driven drilling machines. That is about the biggest thing that happened in the industry the last 10-15 years. And if you are mass producing or having one product or brand, you are going to make that better and better. You are getting up with the quality, you are most likely getting down with the price. And that will help you to earn more money, and it will help the customer to actually be able to buy the house. So it's a lot of things that are good there. Then I do think that the future have more to give us. There we also can be more flexible than the automotive industry. We have learned so much during the introduction of this to the modular industry. So I mean, the product could be the hardware that you are selling to your customer, but the product could also be a software that is just making what your machinery is allowing you to make. And it's not going to, the designer cannot make anything that is not going to be able to produce. And that is very different from how all other industries or all other are working in the construction industry, because they are fully based on CAD systems that are very free in what you are doing, and the design can be made in so many different ways. So it never really get a good flow through the factory if you are doing snowflakes.
So you're a big,
really the right way right now, I think. But we will also have a bit more flexibility. That could be a case for you as well in the future.
so Lars, I think what I'm hearing you say in our visit and today is that it doesn't have to be so rigid that the robot does one thing, but there is a range that the robot can do, and CAD programs or Revit programs that architects use to design a project don't operate in those parameters. No. And so you throw this thing over the wall and say, go build this in the factory. And the robots are going crazy because they're outside their bandwidth of flexibility that you think you can teach them to have. And so you just can't get the routine. If you don't have the routine in the factory, you can't get quality, you can't get speed, and you certainly can't get price down and volume through the assembly line, because everything's a new snowflake every time a new project comes in from a developer.
Yeah, I have a little slide here that is not really, it's more my view of the market. So it's not said to be exactly right, and someone is maybe going to be upset about this, but this is my view. And to the right, we have a car factory, so to say. It's a very standardized production line. To the upper, we have a really high automation in that could also be a car automotive industry, and up in the right we have the automotive industry and quite a lot of other industries as well that are really highly automated, and they are mass producing standardized products. In the other corner we have the unique production and we have manual production, and I am just stating that we are probably 95% of the offsite manufacturers are down here somewhere, because they are extremely flexible in the product and they are very, very manual. And then we have all the different types. I pointed out Catera just because it's everyone knows Catera, but very few are actually pointing out what was the problem with Catera. And I would say it was the data. They spent a lot of time into the machinery and they had a lot of machines, but they couldn't control the data and the design, and they couldn't supply to the customer what they promised. We have another of other customers up there or suppliers that are highly automated, but also very flexible. We below the line, we have actually, it seems to be very dangerous actually to be down there in the manual and unique production area. In Tekra, they have announced that they are going to close down Lindbäck's, the most automated factory in Sweden. They have closed down the automated part of it and are running a manual factory. That sounds so weird for me, and the only reason I can see is that yeah, they don't really control the data. And in Tekra, my vision of it is that they also had an enormous amount of people just trying to produce data to the factory, even though they had some automation in it. Top Hat that we are working for in UK, they have a factory 1 here, and that one should not survive if they did not plan for a factory 2. And the factory 2 is going to be the largest one around, 650,000 square feet, and filled of automation, supplied by KUKA in Germany. So that is a really high-end factory. The question is just if they are going to do a standard production or if they are leaning towards the unique production and how well that will turn out.
And Lars, that's your client.
That's my client, yeah. We are working with them. BoKlok is a Swedish company that are actually using Top Hat. So BoKlok it's an Ikea partly owned company. They are using Top Hat for many things of the house production in the UK. And then we have ZenniHome now that are highly standardized. Your product is really a standard, but you are also very manual. And the question is where we're ending up in the future. And as far as I see, and the potential for your company is to be really up in the right corner, very close to now automotive if you want to, because you have the design for it.
So Lars, Catera's out of business, and Tekra's out of business. You said that Lindbäck is closed in Sweden. Their automated factory, Autovol, is still functioning very well in Boise. I only see 1 or 2 companies in the United States here. This is pretty much, why is Europe so represented so well here on the matrix of home builders who are building in the factory?
We are more used to it. I mean, America is coming strongly now, I feel, because of the war and everything going on here. It's really not much happening here, even though we have been very good in developing our house production technology. So a lot of it comes actually from Sweden as well, and are spread out over Europe. So it's more automated factories in Europe than it is in America. I've been around in America to quite many factories, and they are all very manual. And you also have different way of producing. You are producing a quite small box or module. If you're looking in general, the American boxes are 75 or 80 feet long and 16 feet wide and huge, and it just becomes more difficult to automate that type of production, even though we are doing it for Autowall and others. So So it's possible, but making smaller boxes that you are not keen of, more than you and a few more, it's a difference as well.
Lars, I just toured a factory in Provo, Utah that makes cars, and they're trying to build homes the same way. And they basically are breaking down home production into what they call vehicles.
Mm-hmm.
And they have a size they won't exceed, and I think the size is 8 by 14 or something.
Mm-hmm.
And the reason is that robots have to stretch a long way to get to all sides. And when you have a box, say the size that Autovol builds, you know, that's 16 feet wide and 72 feet long or something, that's difficult for a robot to maneuver around that big of a floor plate to automate. Is that what you're saying?
No, not really, because what I'm saying is that you need to make your design for the production, and this is the Autovol factory. What you see here, it's a wood framed factory, and they are doing these extremely large products. The walls, floors, and ceiling are up to 80 feet and 16 feet wide. The walls are up to 10 feet high. So they are building these big things, but you need to design for your production. And I guess these guys that you are talking about, they have a design that makes it difficult to do big things. So therefore they are doing the smaller ones.
Well, and they're hoping to bolt together to make a unit, modules. You might think of pods, but they bolt these together. And I think one home takes, I think it was 12 of what they call vehicles. Bolted together gives you one 800 square foot home. So
that's fine, but I just believe that it's better to get together as much as you can in the factory and do as little as possible on site. That's my belief. And therefore, I don't believe in very, very small units. They should be possible to transport, and then you are doing everything possible in the factory. And when we are coming to your product and the next generation factory that we are discussing, I am a great fan of actually doing the more advanced part of your module as a pod. And that means the bathroom and kitchen and all the media and hopefully all the heating system, the cooling system, as much as possible of your mechanical installations should be done in one of these small units that then are lifted in, and then the assembly line becomes very short and fast.
I agree. And you and I have talked a lot about, we've got to get rid of sheetrock, and we probably have to get rid of tile. It takes a long time to dry, and sand and paint. And so we're looking at different panels and different things that are beautiful and finished, but we don't need to wait on the assembly line for drying. So what do you think? Toyota taught the automobile industry lean principles that led to speed, quality, cost reduction. Tell us how you feel about lean applied to home building factories.
I think you can apply most of it. In the UK factory, they are using people coming from the Toyota actually in their new factory that they are building up. But in my opinion, lean is really common sense. Actually, it just rules that if you are following them, it makes your production be more efficient, and you are learning from your errors and do it better next time. So it's more common sense, and you can adopt Toyota lean system, but you can most likely do it. You can be very efficient just using common sense as well. And I do think that if you are automating, you are getting in a better position, because the automation itself is going to restrict your way of doing things. Both in terms of designing and how you are actually producing it. And therefore, it's so extremely important that we are looking into this area in the early stage and make it correct and think it through. And there we are coming into another topic that we are very keen of talking about, and that is a digital copy, that we are making a digital copy of your factory, and we are running that digital copy with the same data as we are using in the real factory. And if we can produce real data in the early stage, we can run our simulation and digital copy. It means that that factory is going to work, and we will see all the bottlenecks, and we'll see all the problems. Even though, of course, we are not seeing exactly everything. And that will be a tool to use over the whole lifetime of that factory, because as soon as you are going to do some changes or so, you can test it. Sequencing, we have seen that in many cases, that we can get out a box or two more per week if we are just sequencing the wall production differently. And that is impossible to see if you don't have a tool that is showing you that, and you can play with and run the 4 weeks of production and see what happens. So all the factories around the globe, none of them have a digital copy, I would say. Not
So
one factory.
So let's talk about that. You know, I've seen at ASU, Arizona State University, has a cave where you go in and let's just say someone has to go into a nuclear reactor to do a repair, and it's in, you know, it has to be planned and practiced. The only way to do that is to do a digital copy of the procedure, so you know what tools, how much space you have. You can only be in there a certain few minutes, or you've taken too much radiation exposure. So the idea of a digital copy of the factory that you can run processes and run data through and see what your real bottlenecks are going to be. Why don't you show us, Lars, what you've started to put together for us? And this is rare, that someone would pause before they build an automated factory and actually build a digital copy and run it to see what your speeds are going to be, what your bottlenecks are going to be before you go do something in the real world. Please share.
This is actually a very early stage. We have just been working for a few weeks with ZenniHome. So what you see here is the layout that we have made, and we have LGS production down here. We have a sorting area and buffer area over here. We have another area there. We have pre-assembly of the LGS frames. So it's a floor ceiling line, it's a wall line. And
these are actually, Lars, these are our units exactly. And the building's about 250,000 square feet. And you have a wall line, a ceiling line, a floor and ceiling line. And then you have a pod area to make bathroom and kitchen pods, and a place to make the chassis that we currently use.
Yeah. And over here is the chassis production, and then we have the assembly area of we're sending in the chassis, we are applying the floor, we are applying the pods in the next station on the ceiling, and lastly we are adding the walls. And then it goes into the assembly line. That we just hope that it could be quite simple, because we have made most of the production of the hard or difficult production in the pod area. They were adding as much as possible. But that is a design phase that is part of our proposal for ZenniHome. The factory one that you have now, you have your production and you are doing it manually, so it can be done in different ways. But if we are going over to a more high-speed factory, we just feel that we need to design, we need to do a few changes in the design, so we are going to be more efficient on the floor.
So go ahead, you have a little video that shows that a little bit closer up front, a little bit more personal.
I changed yeah, I can just show you. This is, by the way, what you saw in the background here is another very interesting thing, is how you are stacking the chassis on top of each other.
And that's an actual photograph of last week, showing the developer that's building 29 West by the way, I went by and the building's almost completely demoed by now. And these units, we're going to deliver 180 of those boxes finished to that job site when the podium is finished in August, September.
Yeah. So when we are doing a simulation like that and dig into the data and do the simulation, we're looking into all the manual work. And in the end, we also have the manual work really figured out. That is giving us a lot of information that can be used for all kinds of things like training and education, and the per case of the machinery. It helps a lot if we have details for how this is going to be made. I have a film somewhere. Let's see if I can find that. This is a very, very fast film, so you don't see much of detail, but it's the complete factory. They were flying through and see the different.
These are ZenniHome units, the 640 units from the layout that you showed us previously.
Yeah, and it's actually data. It's no CAD here. It's data. It's pure data coming from our analysis of the product. So we are creating the data coming from the product, and then we can make the image of them and do the production in detail. So
and so you think that this factory could be 250,000 square feet and maybe run by less than 100 people per shift?
Yes, that is what I believe.
And build how many homes a day? 10 or so?
What we have calculated on so far is 8 boxes a shift, but that means that you will do 12 homes if you're running in 3 shifts. But that is a discussion between us we need to go through, because we are not saying that the limit is at that rate. It's just that is the rate we stated, and we have designed the factory for that rate.
Right. And so at 12 homes per day, 365 days a year, that puts you in the range of the most productive factory in the world, probably.
Yeah, the top hat factory in UK is meant to be very, very fast in their production. So let's see, but it will be a very good rate coming out. But the top hat factory is also a lot bigger. So I mean, if we are making your factory bigger, we are able to do it faster, more equipment and so on. But it's also a sweet spot there. You may stay in a smaller factory and then you make another factory that could be somewhere else closer to the market also.
Great. I have one more point to make, Lars, and then we're going to take some questions from the audience. I know that you're very non-committal on wood or steel. We've made a commitment to light gauge steel and red steel chassis, like cars are made. I think you're trying to maintain flexibility to also produce with wood. A lot of countries, Scandinavian countries, some parts of the United States are counting on wood remaining a viable raw material coming into an automated factory for homes. Do you want any comment there? We're going steel, but a lot of people still want to stay with wood.
Yeah, I mean, I can see a lot of positive things of using actually wood in an automated factory. And one of the reasons are that if you have the automation, it's actually going to correct the wood, even though it's bent or twisted. You're kind of correcting it, and then you're nailing it together and get a really good product out of it. If you have automation, if you don't have automation, it becomes messy because you're not correcting it properly. It is some other things that it's easier to insulate a wood frame rather than a LGS frame. The transfer of heat and cold is also a little bit different, but mainly I don't really care that much. It's a matter of design again. You are insulating your LGS frames from the outside. That means that the transfer will be very little. You are thinking that through in a good way. So it's really a matter of design. You need to decide what you are going to use, and then you do the best out of it. And of course, in Arizona, it's not much wood, so steel makes sense. In the Arabic countries, it's the same. They don't have the wood. In Scandinavia, yes, we have so much wood. So of course,
Well, and I think if you're worried about transfer of temperature through steel versus wood, wood does have some insulative value. You just have to look at, we have a rock-on product that has 2 inches of foam insulation on the outside of the frame, and then we have bats between the studs. So we've thought through the transfer of temperatures, hot and cold, through the wall. But it is something to think deeper about than wood, because wood acts as an insulator for sure. So anyway, rather than get into the weeds too much on material,
my point.
why don't we see if there's questions from the audience, and we can hit anything else, Lars, you want to say on that.
My point is actually that it's not that black and white. It's just that the design need to be made for whatever material we are using, and it doesn't mean that it's right or wrong. So I'm open for all kind of materials, but it should be good for the earth and for the next generation and so on.
And I think, Lars, the concluding thought here before we take questions would be, do you really see a future in America where homes are built more in the factory than on site?
Absolutely, it's the only way. I do think that the competition will go in that way. It's just that it takes some time before you have a couple of factories that are doing it and the competition becomes real. Now we are producing very, very expensive buildings manually, and also in automation that is not functioning properly. As soon as we are coming into real competition, it's all going the same way as the other industry that we have. Quality up, prices going down.
Yes. So the more the machines can do it in a factory, in a climate controlled environment, you get safer for people, faster, higher quality, work out the bottlenecks, and you get quantity out the door. Therefore, price is better.
Yes.
Great. Let's take some questions. Do we want to have Maggie? Do you want to help us with the questions? I don't see any in the Q&A.
Sure. Yeah. So number one, from Harrison Langley, he says, "What do you think of the Japanese company Sekisui, which builds a very nice factory-built home?" So I guess they're another maybe factory-built home company.
I actually don't know much about them. Is that the factory in Japan? Because I know they have really a lot of inspired factories coming from the automotive, and they are very different in how they are making the factories. But I've never been there. I would like to go there, have a look.
Great. And then
I see another question, Maggie. Here in Colorado, metal equals lower fire risk. I think that's true in California as well. And so, yes, we take cold rolled steel, we run it through a frame CAD machine from Auckland, New Zealand. It can make 1.5 miles of light gauge steel studs per hour out of a cold rolled steel, galvanized steel. And it is cut to 1/32 of an inch accurate by the machine. It's every penetration is made by the machine that the plans call for plumbing, electrical, etc. And literally a crew with a screw gun and some screws basically put it together. And when Lars gets his hands on these studs, it could be a welded, like automobile company, it could be a welded connection a robot does, instead of having to screw these studs together. So it does help in fire-prone areas. California, Colorado, where you're building in high forest fire risk areas, lower insurance rates if you're using steel studs. Okay. Can you put 2 modules together to make a bigger unit? Absolutely. What we're doing in Mesa with the building behind me, the demo work started this week, I told you, and this site will be well into production in a couple of weeks. we're basically putting 180 boxes together, what we call our A and B box from our large and our small unit. And 180 boxes are building the building, and there's no need to scaffold the outside. That's cladded. Every apartment comes fully furnished from the factory. It's painted, tile, flooring, everything is done. And we're doing that with 180 modules. So yes, this is the idea that we can combine these modules and make almost anything. Let's see, another question here. Water. Water is a concern. How well do hydro panels work in this climate? Hydro panels can produce less atmospheric water harvesting in Arizona because of 10% humidity, but it can still make some. But we are taking water from the city system, the potable water, and we're taking all of our plumbing goes to gray water and black water systems. So our shower, washer, dryer, and sinks go to gray water, and our toilet and our garbage disposal in the kitchen go to black water. And so you're saving over half the water that can be reused in most jurisdictions with a charcoal filter you can buy for $400 from Amazon. And so you're reusing water that you're getting from the city. In Arizona, with the big water issues now with the Colorado River drought situation, except for this winter, it's going to be critical that we have homes like ZenniHomes that will not need nearly as much water for a 100-year certified water supply. And so we're also looking at ways to get the black water processed into gray water so that we can use 98% of the water that you take from the tap on the street and keep it on the lot and use it for other purposes. Atmospheric water harvesting from a hydro panel would just be some drinking water that's augmenting what you're getting from the city. Okay, more questions here. Which one do you want to take here, Lars? Let me go to one here and I'll let you answer it. Follow up on wood versus steel. As I understand, steel modular is about 40% more costly than wood, which are abundant just north of Utah state line. Are you finding potential appetite from developers, even at the higher selling prices? I could just confirm that we can make steel studs as cheap as wood studs at the price of steel today and having our own machine. But go ahead, Lars. Generally speaking,
having a chassis like you have is of course adding some cost to it.
Yes.
But you do get an extremely good structure in your module. So that means that when you're transporting it, it's going to be less damage on it. If you have a wood structure or also LGS structure, it tends to be some cracks and repair work to be done at site as well. The other thing is that if you have the chassis structure around in your mechanical solution, it means that you can stack them on top of each other in a very precise way, and it helps you a lot when you're doing that. So it's a number of reasons for having it, but yes, if you are just comparing, it could be that it's a little bit more expensive one or another way of doing it, but in the end it might be a win anyhow.
and Lars, I don't know if you can pull up your picture again of the stacked modules in the frames. Yes. But I'll just tell folks as you put that picture up, we took our first two models, 4 boxes, to Mesa, didn't break one window, one door, very minor tweaking of things inside the unit. So look at this steel welded, squared, and we were a 1/16 of an inch off in square. You cannot get this accuracy with wood. And when this goes down the road, it's not moving as much as a wood. You'll also see at the very top, I don't know if you can zoom in on the top, Lars, but we have top pick pins in the top. We do not strap the bottom of these units, which all wood modular has to be strapped from the bottom. It's not strong enough to carry from the top. We can literally lift these units, and did lift these units with these hooks on the top. So you top pick, set it, and then just remove the hooks and go to your next unit. There's no bottom strapping the wood modules require, because these are so rigid and structurally very comfortable being moved around. So great. Let's see. Is there any other questions there I missed, Maggie? Go ahead.
Yeah, so we actually have quite a few. Are you able to see the Q&A box at the bottom of your screen?
Yes.
Okay, great. So I guess one we could do is, will the 29 West building use the new pod bathroom or manually built bathrooms? And how soon would the pod style bathroom be implemented at the factory?
Great. I'll just tell you that the 29 West construction will not have pods. We will build those as much as we can offline, but they won't be true pods that Lars has in mind. I think there's a shot that by next year, we could have a pod operating at our same site. And we would have, Lars, how many did you think we needed to feed 12 homes a day?
How many what?
How many pods did we have to have? By the way, I have the Navajo president here. I'm going to go on mute and let you guys talk about it.
Yeah, the number of pods is the number of buildings or homes. So if you have two modules in one home, that means that you have one pod for the bathroom, and it will most likely be one pod for the kitchen, because they cannot be built together as the chassis is too small for that. The chassis, it's another thing with ZenniHome. They have decided to just go for 8 feet wide chassis, and that is because of container sizes. And the idea was that it would be easier to transport, and also using trains for transportation. They are also looking into a wider box now, that the plan is to have 12 feet wide box, and I think that would make sense, because it's going to be a little bit more room, because the boxes is actually taking some of the space. You will get a little bit more walls within the box.
All right, awesome. And then we'll probably take 2 more questions before wrapping this up. Looks like one of the more popular questions is, how long do you estimate a fully functioning automated factory could be up and running?
Yeah, that is a common question. And I would say that normally, if we are getting engaged with the client and customer, what happens in the beginning is that we start analyzing the product or the data or the modules, and then we are asking for, of course, the production rate that we are thinking about, and then we are doing a study, we are doing the layout, we are kind of building up the production, and we are doing some simulations, and that work takes about half a year. But that means that at the end of that time period, we have the whole RFQ, the question, the request to automotive or automation company, the supplier of the machinery, ready. So that starts in the end of that time period to deal with different suppliers. And then it takes about a month to get an answer normally. And then it's order of the machinery, and the machinery usually takes something around 3/4 or 9 months. And if you are going to build a building, it's about the same time period. So if you can kind of getting that going at the same time, you are more or less ready to start installation 1 year and 1 quarter after you started. And then it's a ramp up period of some time as well. So if you are starting up something now, you are probably able to start slowly production in the beginning of 2025.
Amazing. Thank you so much for sharing. And last words before we end for today is ZenniHome actually currently has an open campaign where they are allowing everyone in their existing network, their friends and family, their customers, if you're on the reservation or wait list, you can actually invest in ZenniHome itself as a company, and they are launching publicly tomorrow. But right now they're still in stealth mode, so you are able to get your investments in before they launch. And Bob, if you have any additional comments you wanted to say about the ZenniHome WeFunder campaign.
No, we're excited to make this available, and for people to be able to spend as little as $250 and join our community. We're honored to have you as part of the ZenniHome community. And when you're ready, we'd like to sell you a unit. And for developers out there, hopefully you can afford more than $250 to join our community. And we'll be ready to take your project like the one behind me. That's a beautiful state-of-the-art project. The city of Mesa has approved. The state of Arizona has approved. Everything's licensed and certified, ready to go. Fire department's approved it. This is going to be a beautiful, one of the most beautiful buildings in downtown Mesa. Join our community, and hopefully someday you'll be able to live in one of our homes, or have it as a lake house, or maybe a mother-in-law quarters, a granny flat in the backyard. Some reason you'll need one someday, I'm certain. So join our community, and we're excited to have you on the call today.
All right, well, thank you so much. We will be sending out a recording as well as a link to their page in case you missed it. And be sure to check out ZenniHome. Thank you all so much for coming.
Thank you.
Thank you.
Thanks, Lars, for staying up.
Thank you, Bob.
Get a good night's sleep.
Thank you.
Bye-bye.
Bye.